Hello, everyone. I'm Marco Slot, and my talk is going to be about PG Lake, which is an open source extension for connecting Postgres to the wonderful world of data lakes and lakehouses. I'm going to talk about how you can use PG Lake to import, query, export data in object stores and use it for fast analytics using table formats like Iceberg and file formats like Parquet. All right, so let's get started with PG Lake, Postgres as a lakehouse. But what does that mean, lakehouse? I have to admit that when I started this project, I didn't really know the term lakehouse. I had heard it, but I didn't really know what it was. And it sounds also a little bit like a marketing term, and it sort of is, but it actually also points to an important architectural trend that has been happening in the data space, in the analytics space. So I think over the past few decades, like most companies organize their data in two ways, usually not one or the other, usually both. One is a data lake where you have something like object storage and you collect files, lots of files, log files, CSV files, Parquet files. And it's a very easy place to write to. Any application can just, add more files. Usually there's no limit to the storage. The storage is pretty cheap, but then processing that data can be pretty complicated and slow because maybe the files all have a slightly different format and need to be converted, and they're not in an analytics optimized format. But it's a very accessible, kind of interoperable storage layer for data. A data warehouse kind of structures the data into tables where you have columns and types, and you can do joins, and they're usually very efficient, and so that's a very nice model, but you have to put some effort into structuring the data, and it usually has a particular client and SQL syntax that you have to use. So it's less accessible than a data lake. So a data lake house is basically the combination of these two architectures that you store the data in an object store like Azure Blob Storage or Amazon S3, but it's structured like it is in a data warehouse as a table with columns and types, and you can do SQL on it. And so there's certain table formats that have been defined that can be stored as files in object store and then also modified, and you can do schema changes. And I think the most notable and most popular one is called Iceberg. So we'll talk about Iceberg more because it's in a core part of PG Lake. But Iceberg is basically an open table format. So it defines a protocol, a format for grouping a set of files into a table and defining what the current schema of the table is, what are the past versions of the table, some statistics on the files. And this is in like open spec. It's very community driven. And so lots of different engines have implemented support for querying Iceberg or for writing Iceberg tables. And that allows you to use different engines on the same data. You store data once, you can use different engines. Um, and on those tables, you can also do transactions, which is very powerful. And you can change the schema. There's facilities for things like partitioning and other important features that you usually find in a data warehouse, but implemented in top of effectively a data lake. So PG Lake essentially brings this technology into Postgres. So number one, it adds Iceberg as a really native feeling table format where you can create Iceberg tables from Postgres and query them and do updates or import existing Iceberg tables. But it also actually connects you to the sort of kind of more raw data lake where you can import and export and query Parquet files, CSV files, JSON files, and even some other file formats, um, and work with those very easily via SQL. And then when you're using Iceberg or Parquet, it can also run very fast queries on analytical queries on those tables by delegating part of the query into another query engine called DuckDB. And then finally, I think one of the most powerful things about PG Lake is really that you can do these things in a way that's just using plain SQL and with transactions. And that allows you to build these kind of relatively simple data pipelines where you continuously take data from your data lake, ingest it into Postgres, or archive it into Iceberg. And I'll show you a few examples of that later in the talk. So PG Lake, we announced it in November as an Apache licensed open source project, but it has a bit of a longer history. So we started in early 2024, and in that year we developed it at Crunchy Data, and we added it to sort of Crunchy Data products. Um, and so in November we added the initial Iceberg in Postgres product, but then in June last year, we were acquired by Snowflake. And so within Snowflake, PG Lake sort of took on a new meaning where, well, A, it became an open source project, and B, it became a very core part to the Snowflake Postgres service. But it also became more focused on the interoperability aspect between Postgres and your data lake and Snowflake and other engines. So some more concrete examples, like this was all dry talk. Let's look at SQL. So one of the things you can do with PG Lake is you can create a table directly from a file, and it's very easy because you don't actually have to specify, what the file looked like, what columns it has, what types they have. It'll try to infer that by just sampling the CSV file, looking at the header, and constructing the table that way. So that makes it very easy. Just query a raw file. You can also load more data into that table just using copy commands. You can give URLs pointing to CSV, pointing to Parquet. Um, Now, maybe you don't want to load the data into Postgres because it's a lot. You can also create a foreign table that points to a file or a set of files using a wildcard. That's actually a very nice pattern because if new files show up in that prefix with star.parquet, then if new Parquet files show up, then they'll automatically show up in this table. And one of the nice things also about having the data in Parquet is that when we query that table, we'll delegate part of that query into DuckDB, which is much faster than Postgres. Um, and finally, you can also export data from Postgres. Just run a run a query and export the result back into object storage. And that's really nice because then you can build these pipelines where Postgres imports some data that's maybe written by one application, does some processing, exports it to another application. Maybe your web application or mobile app can directly fetch it at that point. So it really becomes more of this hub in your overall data architecture. So, but dealing with files is always a little bit nasty because it's very easy at first, but then you have a lot of files and they're all a little bit different. There's no you change your naming scheme a few times. Now there's more columns in the newer files, or something got renamed, or is a different type. So that's where organizing things into a table becomes very useful. And so Iceberg is a way to essentially take a collection of Parquet files and give it a structure through a layer of metadata files that describe statistics, which set of Parquet files are currently part of the table. It can specify things like this Parquet file describes what's deleted from this other Parquet file. It can also give statistics of or store statistics of the Parquet file such that an engine that reads those metadata files doesn't necessarily need to go and read the data files for a particular query. And so an engine that implements writes into Iceberg, like PG Lake, it will translate those writes into the generation of data files, Parquet files typically, and these metadata files that reference the data files. And so there's one top level metadata file that's like the current version of the table with the schema and like with the current snapshot, and it points to the sort of the latest version of the files. Um, and so once you have that metadata file, you can discover exactly what's in the table. But to actually do transactions on these tables, like the object stores in which these files are stored, are not suitable for that. They don't really support transaction mechanics like Postgres does. So the way that's solved in Iceberg is essentially by using a database, where it's usually called a catalog. So a catalog is basically a database with an API, and the catalog stores the latest version of the metadata file. And so when we do a write or do a transaction on an Iceberg table, we write a bunch of new files, and then we tell the catalog, hey, here's the new version. And if that last step fails, then essentially the transaction rolls back. And so that's what gives us real kind of transactional guarantees. Now, there's a lot more to an Iceberg implementation. So one of the things that tends to happen is you insert, you insert, you insert, and now you have lots of small files. And so what PG Lake does, like every 10 minutes, a background worker wakes up and it goes and sort of smashes those files together. That's called compaction. So maybe you had, a few 1 megabyte files. Now they become one big, 20 megabyte files. Um, you can also do things like partitioning in Iceberg, but you can also actually use all the Postgres features in PG Lake. Like you can use sequences with Iceberg tables and triggers and constraints. So it's really a deep integration. And essentially, we say they walk and talk just like Postgres tables. So you can create a table using Iceberg instead of using heap. So what that looks like in Postgres is essentially you just create a table using Iceberg. And other than that, these tables behave just like Postgres tables. You can insert, you can update, you can add columns, drop columns. You can have sequences and other features that you might want to use with Postgres, like stored procedures. You can do queries and stored procedures. Um, but the big benefit is that they now sit in cheap compressed storage and essentially infinite storage. You can also do very fast analytics on these tables because the queries are delegated. And they're very accessible to other applications. Like other applications can just directly get the data from object storage. They don't have to talk to Postgres. Now, of course, there are some trade-offs. You don't get everything for free. So a limitation of Iceberg tables in PG Lake is you don't have indexes, you don't have foreign keys, you don't have row-level security. Those are kind of general limitations of Iceberg. So yeah, maybe there are actually proposals to add indexes as well. So maybe we'll have it in the future. Now, the way this is achieved, like that we have just this whole new table format, is through extension APIs. And so Postgres gives you the ability to, as an extension, to intercept pretty much any command that comes into the server, any SQL command, any DDL command, any DML command, and do something different or additional to what Postgres would normally do. And so we can intercept alter table commands on Iceberg tables or queries on Iceberg tables. And then, for example, when we get a query that only includes Iceberg tables, very often we can delegate that query into DuckDB, which makes it very fast. But we really use a combination of many different types of hooks in Postgres to kind of create this very seamless experience. Now, under the covers, one of the things we did was so we integrated DuckDB, which is this multi-threaded vectorized query engine. It's very fast for analytics. Last year, I gave a talk kind of explaining why it's so much faster at analytics than Postgres. Um, but it's also like has a big thread pool. It uses a lot of memory. So one thing we couldn't do is put a DuckDB instance in every Postgres process, because whenever you connect to Postgres, you get a new process, and if we have DuckDB in each process, it becomes we'd run out of memory very quickly. So instead, we have this extra server that we run alongside Postgres, and all the Postgres sessions connect to that server. So when a query comes in on Iceberg tables, the query optimizer in PG Lake will check what part of this query can I delegate into this PGDuck server, and it'll send it there. And we actually implemented the Postgres protocol, so we're just talking Postgres to Postgres essentially. Um, and then DuckDB will get that query and execute it, and it has the credentials to talk to S3, so it can fetch data files, and it often will fetch like parts of data files to not have to download all the data. But it also has a cache that where we sort of store all the files, so often it doesn't have to talk to the object storage at all. Now, having the data in Iceberg is very useful, and because now you can do fast analytical queries, other systems can query it. But how do you actually, in practice, get it into Iceberg? Like when we first built this, we thought, "Oh, this is great. People will use this," and then we realized something is missing. Like there needs to be some piece that helps you get your Postgres data into Iceberg, or your Iceberg data into Postgres, or your data lake data into into Postgres. And so this piece what became PG incremental. And the basic idea with PG incremental is that you want to select, like you have some incoming data, and you want to move that into a different table, let's say. And the first time you do that, you want to take all the existing data and move that. And then after that, you periodically want to take all the new data and move that into the destination table. And so we look for a pattern where we can do that for different types of source data. So maybe the source is a Postgres table, which has a sequence number. And so PG incremental helps you run a query where you take all the sequence numbers that haven't been processed yet, or you can run a query where you divide the data into time periods based on some column, and you take the time periods you haven't processed yet, or you look at the object storage, see which files are there, and the first time you take all the files from there, and as new files show up, you just take those files. And the guarantee it gives you is that it processes each input value once. Um, so each file will be processed once, or each row will be processed once. And so an example of that, for example, maybe you have events coming into Postgres. It's a very common pattern that you have devices, maybe they insert records into Postgres continuously. So there's an append only table. It has very low response time from the application perspective. Usually you do something like partitioning to drop old partitions very quickly and to have like faster queries. And maybe you keep like the last 7 days of data in Postgres with some indexes so you can quickly look up the last 10 events or something like that. And then after 7 days, you drop the data. But maybe you actually also want to keep like all the data you've ever collected, just more in a more compressed form and in a way where you can do fast analytics on kind of your historical data. And so Iceberg is great for that. So what we can now do just from Postgres is we can create the Postgres table, then create an Iceberg table that has the same columns, and then we can set up this PG incremental job where we take all the events based on a sequence number. So the first time this runs, it just takes all of the sequence numbers that are already in the table, and then it will run again every minute. And each time with a different parameter. So with $1 and $2 keep changing every time we run this query. And it'll progress. So maybe first we process 0 to 100, then we take 101 to 110, and 111 to 120. And so we keep progressing. And it also, under the covers, does a little bit of magic to make sure we don't like process a range before that range has finished. So if there's still ongoing transactions that are using older sequence numbers, we wait for that. And so this is a very simple pattern. In 3 steps, we have automatic archival into Iceberg with fast analytics, and other applications can query this data. Um, a similar pattern, but still quite different in some ways, is I have a table that I use as a queue in Postgres. So I just need a quick and durable way to write an event somewhere. And I don't need it to be in Postgres. I just need it to be in a place where other systems can query it. So again, we create a Postgres table, which we use as a queue. Then we create an Iceberg table, which we use as kind of the destination. And in this case, we don't really need PG incremental. We can actually just do a regular PG cron job. So it's like a periodic job that runs every 10 seconds, which deletes everything from the queue and inserts it into the Iceberg table in a batch. And so this batching is quite important when using Iceberg. You typically don't want to do single row inserts into the Iceberg table directly because you'll get horrible response times of a few hundred milliseconds, and maybe only one at a time. So that's much worse than Postgres. But if you do it in batches, that's fine. Like a large batch probably also still takes a few hundred milliseconds because the time really goes into writing those files into object storage. And that usually has some kind of initial overhead. And then another pattern that we see quite often is actually going in the opposite direction, where you have data not being written directly into Postgres, but written into object storage, and you want to get it into Postgres. So these could be logs from a different application. Maybe it's writing compressed JSON files, and you want to get that into maybe a Postgres table. Could also be another Iceberg table. It's very easy to make that choice at this point just by saying using Iceberg or using heap. And then so with PG incremental, you can also create a file list pipeline where you say everything that follows this URL pattern, take all of those files and run my command. And it actually does it in smaller batches, so it kind of does 100 files at a time. But so it will insert into the table and select from this foreign table where the file name is in this set of 100. And then once it's processed all of the files that are already there, it just periodically checks, are there new files? If yes, we'll run the insert select command again. And that way, very simply, with 3 commands, you've built this whole ETL pipeline where you ingest data from object storage into a Postgres or Iceberg table. And if it's a Postgres table, you can add indexes and that kind of stuff. And so you'd normally need really quite a lot of tools to build this without something like PG Lake. But the other area where we find this to be an extremely useful pattern, apart from just doing things purely in Postgres, is actually to connect Postgres to something like a data warehouse. Of course, when I say data warehouse, I think of Snowflake, but it can be also another data warehouse. But so one thing we often see now is that PG Lake is becoming this bridge between your operational database, Postgres, and your analytical database, your data warehouse, like Snowflake or other systems. And Iceberg makes that very easy because you just write into an Iceberg table on one side, and then you can query it directly on the other side because it's this standard protocol. And so one thing we did in our Snowflake Postgres service is kind of try to make this PG Lake integration really seamless. So if you create a Postgres instance and you connect to it, PG Lake's already there. And there's also some object storage kind of attached to the Postgres instance. And so if you create an Iceberg table, that's where it'll go by default. You could also place it somewhere else, but by default, it goes into the managed object storage. And so you can extract data from your Postgres table just by running a create table as or insert select. And then immediately in Snow, if you're a Snowflake user, you can create an Iceberg table, or you're not really creating it, you're referencing it. And then you can query that data directly. And then you can do all the things that you can do in your data warehouse. You can build further pipelines there, or you can do some AI jobs, or use all the functionality of both systems combined. So that's pretty nice. So in summary, basically PG Lake is about integrating with your data lake, with formats like Iceberg, with file formats like JSON, and by extension, integrate with other platforms. Um, it lets you interact with data in object storage pretty much through like the SQL you're familiar with, without lots of external tools that you need to run. Everything is sort of self-contained. Especially with Iceberg, you have these transactional guarantees, and that's also what things like PG incremental rely on. That we can do a transaction on an Iceberg, or a transaction that writes to an Iceberg table, but also from a Postgres table. So that's I can do the bookkeeping on what I processed in the same transaction as the actual processing, and that's very nice. And so, and then combine that with periodic job schedulers like PG cron and PG incremental, you can do this incremental processing just within your database. And it also really simplifies your life compared to having a lot of external tools. So, yeah, I hope this gave you some insight on what PG Lake is, what you can use it for. I'm on the Discord for any questions. You can also email me. For now, thank you very much, and see you at the following Posette maybe. Let's see you next year.